Banned in America, UK's controversial three-parent baby tech. A genetic milestone has been achieved, as 8 infants have emerged unscathed from a hereditary condition that could potentially cause agonizing pain and premature demise, all due to the innovative application of mitochondrial donation by trailblazing researchers in the United Kingdom. This particular type of genetic manipulation, currently prohibited in nations such as the United States and France, has sparked a contentious debate about the ethical implications of altering human genetics. A decade ago, when policymakers and regulatory bodies were pondering whether to greenlight mitochondrial transfer techniques, detractors prophesied Frankenstein-like tinkering that would result in offspring with 3 biological parents. However, the diligent efforts of the scientific and medical personnel at Newcastle University have rendered such apprehensions obsolete, as evidenced by the birth of these healthy infants and the elation of their families. Mitochondria, akin to miniature powerhouses, furnish energy to each cell within our bodies. Their genetic material is passed down through the maternal lineage via the egg. Occasionally, genetic abnormalities occur, leading to mitochondrial disease in newborns. This condition affects approximately 1 in 5,000 individuals, making it one of the most prevalent inherited maladies. When cellular batteries malfunction in various organs, children may endure a spectrum of symptoms ranging from muscular atrophy to epilepsy, brain dysfunction, visual impairment, deafness, and diabetes. In severe cases, the outcome is tragically fatal. Despite the absence of a definitive cure, the focus remains on prevention. Women carrying a mix of defective and healthy mitochondria can undergo in vitro fertilization, IVF, coupled with pre-implantation genetic testing, PGT, to select embryos devoid of mutations, or only marginally impacted. Previously, females with fully mutated mitochondria had few options beyond utilizing donor eggs or pursuing adoption until legislation permitted the utilization of mitochondrial donation technology in 2015. Granting Newcastle Fertility Centre the authority to implement it in 2017. Indeed, the procedure necessitates the involvement of 3 individuals. The intended mother's egg and a donor's egg are both fertilized by the father's sperm. The nucleus of the donor's egg is then excised and substituted with the nucleus of the mother's egg, retaining the donor's healthy mitochondria. This amalgamated egg is subsequently implanted into the mother's womb. The infant's genetic makeup will consist of 99.9% from the biological parents, and merely 0.1% from the donor. Hardly a case of having 3 biological parents. Nonetheless, the practice is not without controversy. Certain countries prohibit the employment of this technology due to concerns regarding human germline genetic modification. The laboratory-engineered DNA will be transmitted to future generations, with unforeseeable outcomes. Moreover, an enigma surrounds a phenomenon known as reversion. The findings of Newcastle's investigation, published in the New England Journal of Medicine, revealed that some embryos with healthy donated mitochondria developed mutations during development. Mutations occurred in 12% of one baby's mitochondria, and 16% in another's. Although insufficient to impact the infant's health, previous studies by other scientists suggest that mutations may escalate over time, and the reasons behind this remain elusive. The Newcastle scientists and medical professionals have received accolades for their meticulous approach. They have bestowed happiness upon certain families and instilled hope in others. Nevertheless, this remains an experimental technique, and exercising caution is paramount. Financial constraints are also a consideration. Those who can afford it will undoubtedly seek treatment, but the National Health Service, NHS, is unlikely to provide assistance to those unable to bear the costs. Regardless, this revolutionary research should be allowed to persist, albeit in a similarly judicious manner.